Today we're going to learn about MaterialX. In particular, we're going to focus on how it's used and implemented inside Houdini. Right now I'm at the official MaterialX website, materialx.org. MaterialX is a way to describe shaders for computer graphics using XML files. It was created by Industrial Light and Magic in 2012 and open sourced 5 years later. It has broad support in the industry if you look on the left at the third-party MaterialX support. When you first start learning about MaterialX, the two things you'll probably want to look at are the specification and the code samples. You can see the specification in the header. If you open this and download the specification, you'll find a very large PDF with all the details you could ever want to know about when it comes to how MaterialX operates and how to write the XML files correctly. Fortunately, if you're using a tool like Houdini or Maya, you don't have to learn all of this. They've done that for you, so you can just use their tools to create a MaterialX material. The next thing is the GitHub repository in the upper right. If you visit their repository or repo, this has everything you need, from source code to Python tools, libraries, but a lot of examples as well. In particular, when you look at the MaterialX homepage, there's this beautiful scene with a chess set. The MaterialX GitHub repository contains both the geometry and the MaterialX shaders to be able to recreate this. So now let's see how you can create MaterialX shaders inside Houdini. To get started, here is the Houdini online documentation. If we scroll down a little bit, there's a section for Solaris. Let's select that. And if we scroll down some more, under shading, you'll see a section on using MaterialX and Solaris. Now, it's worth reading this documentation, but I would like to point out a few things before we get started. If you scroll down, there are two tips. The first says that because Karma XPU will not support traditional VEX shaders, MaterialX is the future of writing shaders for Karma. So as the more you use Solaris and Karma, you'll want to use MaterialX. Next, they point out that Houdini's MaterialX implementation supports something called the standard surface node. This is a general purpose shader that for 90% of your use, this is what you'll want to work with. So now let's open Houdini, and I'm in the Solaris desktop. But to make things easier to see, and so I can really enlarge everything so you can see it on your screen, I've created a custom desktop with just those things that we're going to focus on. Namely the viewport, the network editor, and the parameters and the USD scene graph. So what I would like to do is create a lava material and apply it to a plane. So let's switch over to the stage context, because that's where all the Solaris magic happens. And I'm going to use SOP create so that we can go in and have an embedded geometry context and create a grid. There we go. And now let me just add some UVs to this. I'll just use the auto UVs from the labs tools. So there we go. We have a nice grid with UVs attached. And now we're going to create the MaterialX lava shader to apply to this. To do this, we're going to use the material library LOP, the material library node. This is a way to create all your different materials in one place and then assign them. This node will allow us to create our materials. Let me write that. Up above is where we created our grid. After we've created the lava material, we're going to use the linker node to assign the lava to the grid. And then before we go any further, I want to add the Karma render settings to specify that I want to use the XPU engine. I'll reduce the number of paths, and then I will also select a denoiser. So this way rendering will be nice and fast. So now let's come into the material op, and we're now in the VEX context. So we're in VOP land. And MaterialX nodes in Houdini are VOPs. So if you hit tab, come down to MaterialX, there are lots and lots of nodes to do everything you need. Now, the standard nodes that MaterialX wants is a surface material. So let's create a surface material node. And this is like your final destination node when you're building a material. I'm going to call this lava material. Let me go full screen here so I can make everything as large as possible. You can see the surface material has two inputs, a surface shader and a displacement shader. So for the surface shader, if you remember back to the Houdini documentation, there is a standard surface shader. There is called standard surface. So we're going to take this and pipe it into the surface shader. You can see it's very tall because it has all the features you would want. Then we want to pipe in a displacement shader, and we'll return to that after we get the standard surface shader working. So now the first thing I want to do is add a base color, and I have a lot of texture images to build this material for us, and I'll use those. So to load a texture image, you use the MaterialX image node. There we go. And this will be the lava colors. And I will pipe this into the base colors. Now if I select this node, over here on the property, let's load the file. And this is the material I'll be using today, Lava Cracked Medium 001. So I'm going to load the color, and there we go. We've loaded the colors, piped it into the lava surface shader, and then piped that into the material. And the material is just the surface shader plus displacement. So let's leave full screen, go up to the Solaris context, and now let's assign lava to the square so that we can see that it is in fact working. Over here underneath materials, you'll see there's material and surface shader. We only want to use the material, the final material. So if you go back into the material library, you'll see we have the orange flags turned on for both the standard surface and the surface material. We only want the orange flag or the output flag on for the material node. Go up once more and let's revisit the linker. Now you can see we only have the lava material and we have our grid. So I'm going to drag the material over here, and the rule is we want to assign that material to grid. And there you see in the viewport, it's now updated and the lava is attached to the square. It already looks quite nice, but what we're going to do now is just really polish this up with displacement, emission, and a few other adjustments. First off, if you look at it from the top, you can see this is way too specular. Lava does not look like that. So we're going to go back into the library, select the surface shader, and if you look at the properties, there's all these tabs that organize the different ways that you can adjust this material. Base is where you specify just how diffuse it is, color, metalness, etc. Specularity is what's causing this problem. It's maxed out at 1, so if I change this to 0, that now disappears. And so now it has this darker absorbent property that you would expect from lava. So now let's add normals. I'm going to go full screen once more, and we're going to come down here. You can see this is where you wire in normals. And before we do that, let's just hop back over to the Houdini documentation. At the second tip, they talk about the standard surface node. So let's go to the documentation for this. It shows how you can make all these different materials using this one node. It really is a jack of all trades. There is a list of tips, and the first tip is worth noting. You want your normal texture maps to be fed through the normal map node. That will just do the necessary adjustments and scaling to get everything in the right range. So we're going to first load the normal texture map, and I'm going to call this lava normal texture. I'm going to come over and load the file, and it is this image right here. So before we pipe it in, we want to make a few changes. First off, the normals are data. It's not color information. So with the normal texture node selected, you're going to come up to the signature and change it to vector 3. Next, there is a normal map node. That's what the tip told you to use. So you want to pipe your normal texture in here and then take the output and put that into normal. Let's leave full screen, and there we go. Now, if I disconnect this, you can see the before and after. It's not very dramatic, but there are some subtle differences, and when taken all together, it will make for a very nice material. Next, let's add emission. So that way the red stuff will look like it's glowing. We're going to go full screen again, and we can see, if we come down here, there's a section for emission. Now, if we leave this and we select the surface shader, you'll also see there's a tab for emission. So this is where you could select just a color and control it, but what we want to do is use an emission texture map. So we're going to come down here, load a MaterialX image. This will be the lava emission. Come over here and select the file. It is emissive, and pipe this into the emission color. And that's because if you look at the texture file, the emissive file here does contain colors, not just numbers or shades of gray. It does contain color data. And you'll notice it doesn't look different. In fact, we could toggle or we could disconnect the emission image. No difference. And the reason is when you pipe this into the standard surface shader, emission is 0. Just like specular defaulted to 1, emission defaults to 0. So if we crank this up, or as we crank it up, the lava is starting to glow. So here is an emission value of 1 and 0, after and before. Lastly, on this viewport, let's change to the Karma renderer. It will look a little nicer. There we go. Now let's add the displacement. I'm going to go full screen and zoom in. What I'm going to first do is take the surface shader node and minimize it. Hit H and L to lay out. So now we have a little more room to work with. We now want the displacement shader. For that, we're going to use a displacement node. And what this does is this is a lot like normal map. You take the displacement texture, map it into this, and then you're going to pipe this out to the displacement shader. So let's load another image node. I'm going to come up here, load the displacement file. I'll get the large one. This will be lava displacement. So let's pipe this in. So we now have the texture map going to the displacement node into the surface material. Now it's redrawing everything. And in fact, actually it has already applied. If you look at this sideways, you can see there is definitely displacement. And to drive home this fact, if I cut the displacement out, you can't see it anymore. That's because it's now truly planar. There's no 3D aspect to it. It looks 3D, but it's not. If you look at it from the side, there's nothing there. But if you bring the displacement shader in, you can now see that there is genuine displacement and it has a 3D feel to it. So now if we come in on this, we have a nice looking lava material. Now that we have this, what I'd like to talk about is how you can export this material and reuse it in other things. Now, if we come into the material library node, go full screen, and come to the surface material node, the terminal node of our material network, right click, come down to save, we can save this as a MaterialX file. I'm going to save this, and I'm going to call it lava.mtlx. MTLX is the suffix for MaterialX shaders. Accept, and there we go. Let's take a look at this file before we try to use it. Here we go, there's lava MTLX. Let's open that. And you see it's an XML file. And we have a surface material element, and that corresponds to the surface material node. There's a standard surface element that corresponds to the standard surface node. If we scroll down, you'll see a lot of images and inputs. Each image element is loading one of the texture maps. And near the bottom, you'll see a displacement element, and that corresponds to the displacement node. And we have 1, 2, 3, 4 images loaded. And let's count. Here's 1, 2, 3, and 4 images. So there are 4 image nodes. By the way, notice there's also a normal map element that corresponds to this node right here. So we have image, normal map element, surface shader element, surface material element. We have an image element, a displacement element, a surface material element, an image element, standard surface element, surface material, and another image element there. So if you ever run into difficulty, you can quite easily open the MaterialX file and make some adjustments to the XML, but hopefully that's something that you will never have to do. Let's come back to Houdini and return to our Solaris context. What I'd also like to do is take this material and save it as a USD. So I'm going to just cut this out for a bit. So let me pipe this in. It'll just be a plain grid now because the material definition is no longer part of this network. what I would like to do is save this as a USD file as well. And you'll see in a moment why I'm doing this. So we're going to use a USD ROP, come up to the output file, and we're going to call this lava.usd and just save to disk. And then another thing I would like to do is save it as USDA and save to disk. Now, if we look at the USD file, it's binary. It's not going to display. But the USDA is a text file. So here, you can come in here and see how USD represents the material. Reminder, USD files are not XML, they're not JSON, they're their own specification created by Pixar. There we go. So now what I'm going to do is delete this material library and the USD ROP. We now have our grid, a material linker, which unfortunately is no longer doing anything because there's no materials in our Solaris stage. So to bring in a material, we're going to use the reference LOP. Let me bring this in here. And file pattern. You'll notice it's lava.usd and USDA. The MTLX, the MaterialX file, is not visible. You have to come down here and select asterisk to bring up everything. And then you can select the lava.mtlx file. Now if we come down to the linker, you'll see we have the lava material and our geometry. And if we assign them, it doesn't work. Now, when this first happened to me, I went down a very deep rabbit hole to kind of understand why this was happening. But before we go down that rabbit hole together, let me try the USD file. So I'm going to come over here, and instead of the MTLX, the MaterialX file, let's load the USD. We're going to come back to the material linker, and it has a slightly different path here. Notice MTLX displacement there. That's because we left the orange flag on. My bad. So we're going to bring the lava material over and assign the grid to it. And this works just fine. And is displacement included? Yes. If you look at it sideways, the displacement is operating as well. So the material, when saved as a USD, works. But when saved as an MTLX file, does not work. Let's revisit the Houdini documentation and return to the Using MaterialX and Solaris page. If you scroll down, there's one sentence that's actually quite important. So this paragraph here, that Solaris can reference MaterialX files just fine, but writing to MTLX files is limited. And if you want to really familiarize yourself with the MaterialX specification, you could open the MTLX file and try to debug this. I'll give you some clues. I won't do this now because this I don't think is the approach anyone wants to take. But if you really want to understand the XML specification and come in here and see what's going on, the problem is images are at the same level as the displacement node, as the normal map, as the standard surface, and as the surface material. Typically what's done, if we return to the GitHub repository for MaterialX, they have some fantastic examples. Let's go into resources. They have some materials, some examples, some standard surface examples. Let's take a look at the standard surface brass tiled MaterialX definition. This is an XML file, and if you look at it, it has the standard surface node. Once again, everyone is using that standard surface node. It really does everything you need pretty much. It has a surface material, the terminal node in the material network. But look how they define images. Here they define tiled images rather than just plain images, but they put it inside a node graph. And when you look at the MaterialX specification, this seems to be the way that most people use MaterialX. They create a node graph with all your images together and your outputs. And then you take your outputs and wire them into your displacement, your standard surface, and your surface material. When I made those changes to the XML that Houdini generated, it did work for me. But I realized that's not what I want to do. I never want to go in and muck around with XML. And that's why I saved the material as a USD asset. So I hope you found this helpful, and I will see you in the future.